So as we are discussing, we are going to show you the question paper and let's see what the question says. So let's go back to the question directly. So this is the question. I hope this is very clear in the paper. The metal M melts at 1000 K with an enthalpy of fusion is given 10 kilojoule per mole. The specific heat capacity of the solid and liquid M are given, Cp solid and Cp liquid, 20 joule per K and 30 joule per K. Now you are asked to calculate the change in enthalpy. But what is the difficulty? Difficulty is that you have been asked to change the you have been asked the change in enthalpy at a temperature 900 K. See, at 900 K there is no transformation. If it is in a normal state or in a basic state, there should not be any transformation. But you have been asked to find an enthalpy change at a 900 K, which is not at its, it's not the equilibrium temperature for coexistence of liquid and solid simultaneously. So the temperature should be 1000 K, at which liquid and solid both of them are at equilibrium with each other. And you have been also asked to calculate the change in entropy for the process at the same temperature 900 K. So here the important thing you should note that the temperature is 900 K and the equilibrium temperature is 1000 K. So no transformation occurs at 1000 K under normal condition, under reversible and equilibrium condition. So it's a irreversible condition, or not a state of equilibrium. So that's what the question. You can also pause this video and note this problem properly down, and so I'll just proceed. Okay, so this is the question. So let's go back to the board work and see how will you solve this problem. So here is your metal M at liquid state at 1000 K, right? Here is your metal M at solid state at 1000 K. So at 1000 K, liquid is in equilibrium with the solid. Now there is a temperature 900 K. By some process you have supercooled or undercooled the liquid, and you still have this liquid at 900 K. So it is M liquid at 900 K, right? And now you have been asked that this liquid now transformed to M solid at 900 K. So what is the delta H and what is the delta S for this process? Now see, you have no data for 900 K because the transformation doesn't occur at 900 K under normal temperature and pressure and under normal circumstances. What do I mean by normal? Normal, I mean by standard temperature and pressure at which the liquid is in equilibrium with the solid. So it's deviation from the standard state. It's a non-standard state, and that's why it's a reversible, irreversible process, this transformation. So how will you approach it, right? Same thing. Let's go for the enthalpy. So you don't know. Let's again name it 1, 2, 3, and 4, right? So you've been asked to calculate del H 2 to 3, del S 2 to 3, right? So what will you do? Del H 2 to 3, as I have discussed, is nothing but 2 to 1. Del H 2 to 1, then we'll add del H from 1 to 2, then we'll add del H from 4 to 3. Sorry, 2 to 1, 1 to 4, and 4 to 3. The same is for entropy. 2 to 3 is del S 2 to 1, del S 1 to 4, and del S 4 to 3, right? So you add 1 plus 2 plus 3 to get this value. It's a state function. It doesn't matter by which path you have arrived at a state. The only thing that matters is which is the final state, which is a function of temperature. So that's why, as enthalpy and entropy are both state functions, so it's a path independent process. So we can have this addition, okay? And for these three processes, these are reversible processes, so we can calculate the enthalpy and entropy change for this respective process, right? So what is the formula for del H? Remember this, if nothing is mentioned, everything is at Cp is also given. That means that the pressure is constant. So for this process, what is the process of this process? Cp liquid by T, sorry, I'm calculating the enthalpy, so no T. So what is the formula for calculating enthalpy? Del H is Cp dt, right? Cp dt. And what is the process? Calculation of enthalpy? Cp by T dt. Integration. Right? Cp dt and del S is Cp by T dt. So let's calculate the enthalpy first. So for this process, 2 to 1, let's do it. Enthalpy for 2 to 1 is equal to, your temperature starts from 900, you go to 1000 K. Okay, fine. Now Cp liquid is given in the problem as 30. But look at the unit, it's joule per Kelvin, right? So let's say 30 joule per Kelvin, it's in joule. So remember, this unit is very important. So if I need to do it in kilojoules, so I'll divide by 1000, right? Into dt. Okay, so this is the first part. What is this part? 1 to 4. The enthalpy is directly given. It is 10 kilojoule per mole. We are calculating for a 1 mole particle. That's what I've been asked. So for 1 mole, the enthalpy of fusion is 10 kilojoule. Remember, a solid always contains less heat than a liquid. So whenever I were talking about 1 to 4, so it's actually H4 minus H1, right? So H4 minus H1 is negative 10 kilojoule. This is the enthalpy. 1 to 4, right? 4 minus 1. So a solid contains less heat than the liquid. That is a liquid, gives up the heat to become solid. So this is minus 10 kilojoule, right? So del H is minus 10 kilojoule. A liquid gives up the heat, so it becomes solid. Lesser heat. Okay, fine. For this process, now already it has become solid. So we'll now use the Cp solid value to come from 1000 K to 900 K for a solid state. How it will be written? It will be written from 1000 to 900 Cp solid dt, that is 1000 to 900. It's 20 joule, right? Remember, it's in joule. So 20 by 1000 kilojoule into dt. Cp dt, right? This is Cp dt. So Cp solid dt, Cp is 20 joule divided by 1000, so it becomes in kilojoule dt. Now let's see. So I'll just do the calculation inside. So this becomes what? How much? This becomes 30 by 100, 1000, sorry. 1000 minus 900. Integration dt is t. So t, 900 to 1000, 1000 minus 900. Okay? Plus minus 10. Right? So the delta H is negative, so plus minus 10. This is for the enthalpy of fusion, for liquid to solid transformation. Right? This path, the directionality is very important. You cannot just add some algebraic summation. Look at the directionality. So that's why I have started integration from 900 to 1000. It's not arbitrary. You have to see from the initial state to final state. See? So the difference is always between final state and initial state, not between initial state and final state. H4 minus H1. So H4 minus H1 means the solid minus enthalpy of solid minus enthalpy of liquid. Enthalpy of solid is lesser than the enthalpy of liquid, so it's minus. Now for this Cp solid, how much this is? 20 by 1000 to 900 minus 1000. Right? 20 by 1000, it is in kilojoule. 900 minus 1000 K. So if I do the calculation, how much it will be? It will be, see, it's 100. So 3 minus 10 plus, this is, sorry, yes, this is 3 minus 10 and this is minus 2. So plus 9 kilojoule per mole. So the final answer is plus 9 kilojoule per mole is the enthalpy change for M liquid to transform to M solid at 900 K. Okay, so that is the calculation for enthalpy. Now come back and we'll see how to calculate the change in entropy. Let's do that also. You just try yourself. Just pause the video and try yourself. If you're not able to do that, just follow the video. So first thing, what is the calculation for entropy? Formula should be, at your fingertips. So Cp by T dt, right? So integration Cp liquid by T dt, it's from 900 1000 K. For this one, see, remember, it's at constant temperature. This is an equilibrium state. Liquid transformed to solid at a constant temperature. This is a phase change. No change in temperature. This reaction is occurring at 1000 K. So your delta S for 1 to 4 is again minus 10. Let's do it in joule. Minus 10 by 1000 K. This is the temperature. This is the temperature 1000 K. Why I have multiplied with 10 to the 3? It's in kilojoule. So I am multiplying by 10 to the 3 to make it joule, because I will use joule here, because you can check the final answer it in joule. So minus 10 to 10 to the 3 joule divided by the temperature at which the transformation is occurring. It is occurring at 1000 K. Okay, and the third part for the same, it is integration Cp solid by T dt. It's from 1000 K to 900 K. Okay, fine. So integration 1 by T dt is ln T, right? I hope you didn't forget your, class 2 mathematics. So ln 1 by T dt is ln T. That's what we use here. So we'll write this equations inside. So it becomes, so Cp is a constant, so 30 ln 1000 by 900, okay, minus, you see, minus 10 plus 20 ln 900 by 1000. So we can further simplify this calculation. So 10 by 9, 9 by 10, 30, 20. So you can write 30 ln 10 minus 20 ln 10 plus 20 ln 10 minus 30 ln sorry, this is 20 ln 9. You can just plug the values in calculator. You don't need to do this. I just do it because I don't prefer calculator. Try to do it as much as possible by simplifying the calculation. It helps sometimes. Sometimes it cancels out. So you even don't need a calculator. Very simple calculation sometimes. So it is 30. 30 ln 10 by 9, and this is 20 ln 9 by 10. So it becomes now 10 ln, so positive 10 by 9 minus 10. So you just do the calculation. You will find that it will be minus 8.95 joule per T per mole. Okay, so this is the unit of entropy. How do you remember the unit of entropy? You just remember delta is equal to heat by temperature. So unit of heat is joule and the unit of heat is K. So joule per K, if it is for 1 mole, another comes in the denominator, so mole. So 895 joule per K mole. Okay, you normally write it this way, or mole inverse, mole inverse. Okay, so 8.95 is your answer. I hope it clarifies the concept what I have discussed in that class, and this is how you need to approach a problem. So I will just go to that slide. Show you this one. So your answer is minus 9 kilojoule per mole for the enthalpy first part. This is your answer. And for your entropy, the final answer is minus 8.95 joule Kelvin inverse mole inverse. So this is how it's going to be. So always remember that nobody is going to do it for you. So it's a very specialized treatment which you can get only from certain people. So please do remember that this is a very conceptual problem. Otherwise, normally question will be asked simple integration CPDT, and you will be able to do that. I will also solve some simple problems, but these are the conceptual problems. This is one of the most important problems, and people don't understand how to solve this. Remember, this is a reversible process. That's why we need to do a treatment like this, right? Okay.